Alright, so today we're going to be talking about now evaluating with double angle identities. So these are the last of our identities. Okay, these last identities, we'll talk about this whole entire unit. Again, we talked about double angle a tiny bit before our Thanksgiving break, and well, now here we go. So sine of 2 theta is equal to 2 sine theta cosine theta. Okay, cosine 2 theta is equal to cosine squared theta minus sine squared theta. Okay, just a small disclaimer here, this is not the Pythagorean identity. Okay, the Pythagorean identity is cosine squared x plus sine squared x equals 1, not minus. So do not replace that with a 1. Okay, although we can come up with 2 more identities based off our original identity because of Pythagorean identities. Okay, and so what we're going to do is we're going to rewrite this out. Cosine squared theta minus, and where there's a sine squared theta this time around, I'm going to go ahead and I'm going to replace that with 1 minus cosine squared theta because sine squared theta as a Pythagorean identity equals 1 minus cosine squared theta. Okay. After you go through and distribute this minus sign to both terms, you end up with this. 2 cosine squared theta minus 1. So there's our second identity for cosine 2 theta. Okay, and now we have one more. And so again, we're going to write out our original identity here. Okay, but this time wherever there's a cosine squared theta, I'm going to replace that with a 1 minus sine squared theta because cosine squared theta as a Pythagorean identity equals 1 minus sine squared theta. And then don't forget about the minus sine theta. Okay? Or sine squared theta, sorry. And now, after combining like terms, you get this. You get 1 minus 2 sine squared theta. Okay? So there's our 3 identities for cosine 2 theta. Now, how do we know which formula we're going to use and what? Really just depends on what's asking us, what's being asked of us question-wise. Okay? All right, tangent 2 theta, that's going to be 2 tan theta over, just make sure, sorry, my bad here, over 1 minus tan squared theta. Okay, or because of the quotient identity that we learned about before break, you can say that tan 2 theta is equal to sine 2 theta over cosine 2 theta. Now there is a disclaimer with this formula as well, the second one here, right? Okay, we're only going to use if you already found sine 2 theta and cosine 2 theta. It's the only time we're going to use that if we already found that, and you'll see how that differs through these examples here. Okay, so just 2 examples today, so let's go ahead and look at those. Okay, so it says this example, it says find the exact values for sine 2 theta, cosine 2 theta, and tangent 2 theta if cosine theta equals 4/5 and our domain is restricted to 3 pi over 2 and 2 pi. So the first thing we need to determine is that, again, and this is good because we did a couple problems yesterday with drawing triangles. Okay, and now today this whole section is about doing that to come up with our solutions. So the first thing I need to do is I need to determine what quadrant my triangle is going to be in. Well, 3 pi to 2 pi, that's going to be quadrant 4. So then my next step is to draw a triangle in quadrant 4. Now, we start at the origin. Okay, we start at the origin, and how do we get to quadrant 4? We go right down. Okay? At the beginning where we started, right, that's where theta is going to go because that's where our origin was. Draw your right angle here. And now we're going to go ahead and we're going to label it based on what we know. So what did it tell me? It told me that cosine of theta is equal to 4/5. So what do we know about cosine? We talked about this yesterday. Cosine is equal to adjacent over hypotenuse. Well, the hypotenuse side is always opposite the right angle. So therefore, this has to be my adjacent side. My adjacent side is the side that is closest to theta, but is not the hypotenuse. So then we go over here and we say, okay, this has to be 3, but not only 3, it actually is a -3. Please make sure you get your signs correct. Okay? Please make sure you get your signs correct. And the reason why is why is that negative? Because how did we get to quadrant 4? We went over right, which is positive on our unit circle or on our coordinate plane. But whenever you go down, associates it being negative. Okay, making it negative. So we went down, so therefore that has to be a -3. Now, before we're ready to go on and find sine 2 theta, cosine 2 theta, tangent 2 theta, we need to go ahead and we need to find sine theta and cosine theta. And the reason why is right here, look at step 2, use sine theta, cosine theta, tan theta to find those. So I know cosine theta, but I don't know sine theta and tangent theta. Now, we just talked about this yesterday, so I'm going to go through this pretty quick. We should be good at this. I know, but sine theta is equal to opposite over hypotenuse, so opposite 3, hypotenuse 5. Okay? And then tangent of theta is equal to opposite over adjacent. So opposite from theta there is -3, adjacent 4. And so always what you have to do for first step is you have to determine the triangle, draw the triangle based on one of the trig functions being given. So in this case it's cosine, it could be sine, it could be tangent, always get at least one of them. Draw the rest of your triangle and then find the 2 missing parts. So I believe that to be the hardest part, because now watch what we do with this second part here. Okay, so we want to find sine 2 theta. Well, let's go ahead and let's write out what sine 2 theta is. That's 2 sine theta cosine theta. And so all we're going to do is we're going to write that 2, and then now what did we find for sine theta? -3/5. What did we find for cosine theta? 4/5. And now all you're going to do is you're going to type that in as you see it. So I'll show you one time here real quick. Okay, it's going to be 2 parentheses fraction -3/5 close parentheses open parentheses fraction 4/5 close parentheses. And when you do that, look what you get. You get a -24/25. So that is what sine 2 theta is equal to, -24/25. Okay? All right, now we want to find cosine 2 theta. Now I've got options with cosine 2 theta. Okay? I've got 3 different identities here. Okay, 3 different identities. Any one of them will give me the correct answer if done correctly. I'm going to go ahead here and I'm going to use the middle one. And the reason why is this, okay? If at the beginning, if I had a tough time understanding, hey, I got to draw a triangle, what quadrant is that triangle in? I was given enough information to actually find cosine of 2 theta, because all I need is to know is what is cosine of theta, and it was given to me. It told me it was 4/5. So at least if I'm not sure, I can answer at least one of the 3 parts and get some points. So let's go ahead here now. Wherever we see a cosine of theta, we're going to plug in 4/5. So it's going to like this. It's going to be 2, open parentheses, 4/5. Raise that to the second power because we're dealing with cosine squared theta now. Raise that to the second power. First time we've had to do that. Subtract 1. Okay? And now we're going to put that into the calculator as we see it. So 2, parentheses, fraction button, 4/5. Close parentheses. Hit the exponent button here. Don't know why I did that. Exponent button, 2, scroll down, -1, hit enter, and if you did that correctly, you should get 7/25. Okay, so now we've done sine 2 theta, cosine 2 theta, and now we're going to look at tan 2 theta. Well, this is why I gave you this option, is for this exact problem, to make it a lot simpler for you. Okay, I said you could either use this, which you can, because we did find tangent. Okay, all right. A lot of students make mistakes on this just because it's a little bit harder to type in the calculator, or you can use this formula. And I'm going to use this second formula here. So I'm going to say tangent 2 theta is equal to sine 2 theta over cosine 2 theta. Okay? And so all that means is now just plug in what you found for both of them. So for sine 2 theta, we found a negative 24 over 25. All over cosine 2 theta, which we found to be 7 over 25. And now just go ahead, plug that in your calculator. That's two fractions. I think you know how to do that. And if you did that correctly, you would have negative 24 over 7. And there you go. So we just solved for sine 2 theta, cosine 2 theta, and tangent 2 theta. Okay? One more example here now. Okay, so on this next question here now, look what it's asking. It's just asking for tangent 2 theta. Tangent 2 theta. So only one this time, so that seems to be a little bit easier. But now it looks like it's going to be a little bit more difficult to determine what quadrant my triangle falls, because I've got two parameters here. I've got secant of theta equals negative 4/3, and I've got cosecant of theta is greater than 0. So what we've been given is we've been given the reciprocals for cosine and sine. Okay, cosine and sine. All right. So what we need to do is first off, and I want you to remember this. Okay, when you look at your unit circle here, okay, and you should have your unit circle out while you're going over this as well. When we created this unit circle, we did everything in terms of sine and cosine. Okay, we did everything in terms of sine and cosine. So ideally, we want to write everything in terms of sine and cosine. Okay, so what I'm going to do is I'm going to change this secant to cosine. Remember, it's the reciprocal, so to get cosine now, you're going to have cosine of theta is equal to negative 3 over 4. Okay, negative 3 over 4. Now, ideally, okay, what we want to get out of this is we just need to determine now, okay, where can my triangle possibly fall with cosine of theta equals negative 3/4. I'm not too worried about the 3/4. Really, what is going to help me is the negative sign. And so out of the 4 quadrants here, okay, where is cosine always negative? Well, look at all your x values here in quadrant 2. Look at all your x values here in quadrant 3. So cosine is going to be negative in quadrants 2 and 3. Okay, quadrants 2 and 3. So we now know, and why we're given these, because we have to determine again where is our triangle going to fall. So in this case here, we figured out based on one of the parameters that's either going to fall on 2 or 3. So maybe now let's go ahead and check out cosecant of theta, and if we can determine kind of based on where our triangle would fall in this one, see if they match. See if the two parameters match in any one certain way, and then we would know then, okay, the triangle definitely falls in that quadrant. So what I know about cosecant of theta is that it is the reciprocal to sine. Okay, and so if cosecant of theta is greater than 0, that means sine theta is also greater than 0, and here's the reason why. Say you had cosecant of theta equals 2. Okay, say that you had cosecant of theta equals 2. Well, if you were to find sine theta, all you would do is flip it, and you would find out that sine theta is equal to 1/2. Okay? And so what do you notice there? The signs did not change. Sure, the values did because we're finding reciprocals, but the signs did not. So based on those facts, I can also say then that sine theta is greater than 0. So now what that does for me, okay, what that does for me is that That allows me to determine, okay, based on that parameter, where would my triangle fall? And so I go back to my unit circle and I say, okay, where are all my sine values positive? Remember, sine is equal to all the y values. So I got positive values here in quadrant 1, and I get positive values here in quadrant 2. And that is a good thing, because now we know then that based on this parameter, our triangle is going to either fall in quadrant 1 and quadrant 2. And now what do I notice that they both have in common? They both have quadrant 2. So therefore that means then that my triangle now falls in quadrant 2. So now my next step is to go ahead here and I'm going to draw a triangle in quadrant 2. How do we do that? How do we get to quadrant 2? We go left and then up. And where we started, we write theta in. Okay, and so now we're going to go ahead and based on what we know, we're going to fill it out. Well, thankfully we found what cosine, we found cosine of theta, so it's going to help me label my triangle a little bit better. So remember, cosine of theta is equal to negative 3 over 4. And remember, we've talked about this before. Cosine is equal to adjacent over hypotenuse. So my adjacent side, my hypotenuse side. Now, a lot of students, we've talked about this, know your Pythagorean triples, are going to go ahead and they want to label that a 5 because they see 3, 4, 5. Unfortunately, that is not the case. And the reason why is that with all your triples, okay, okay, your biggest side, so in this case 3, 4, 5, is always the hypotenuse because the hypotenuse is always the longest side. Okay? And so to find this missing side, then I am going to have to use the Pythagorean, theorem here. So recall, we haven't done this in a while, but we should still be easy to do. A squared plus b squared equals c squared. Okay? And so let's plug in what we know. So a squared, we're going to plug in as a negative 3. Put a parentheses around it, again, because look what happens here if you don't. I've been saying this a lot. Negative 3 to the second power gives me negative 9. We know that that's not true. When you multiply two negatives by each other, you get a positive, plus b squared. And then remember, my hypotenuse always goes in for c. And so now that's going to give me 9 plus b squared equals 4 squared, which is 16. Subtract the 9, and now it's going to give me b squared equals 7. Square root both sides to get b by itself, and you see that b is equal to the square root of 7. Okay, now, what's my goal? Well, I'm only trying to find tangent of 2 theta. So really what that means is then I just need to find tangent of theta. Remember in problem 1, we used sine theta, cosine theta, and tangent theta to help us come up with the double angles to evaluate them. I don't need to find sine 2 theta or cosine 2 theta this time, so I only am worried about tangent 2 theta, and so therefore let's just find tangent of theta. And so what is tangent of theta? Opposite over adjacent. So opposite is root 7, adjacent negative 3, and so we find that tangent of theta is equal to root 7 over negative 3. Okay, now that I have that, the easy part. Okay, well, tangent of 2 theta is equal to 2 tan theta all over 1 minus tan squared theta. So let's go ahead, wherever we see a tan theta, let's plug in root 7 over negative 3. So we're going to get 2 times root 7. I'm going to put the negative sign out front here because we know that a positive over a negative is going to give you a negative fraction. All over 1 minus negative sign, root 7 over 3 to the second power. I'll show you what that looks like in the calculator here. So clear everything. We're going to go fraction button, fraction in the numerator. Well, not yet. Sorry, we're going to go fraction button, 2, parentheses, fraction. Okay, we're going to go, and actually out front of it, you want to put a negative sign. So negative sign, root 7 over 3, close parentheses, all over now 1 minus, because that's part of the formula, minus button, parentheses, negative sign, because we're having a negative fraction here, fraction button, root 7 over 3, close parentheses, and then raise that to the second power. And there you go. So now just scroll all the way over, hit enter, and if you did that correctly, you should have gotten that. You should have gotten negative 3 root 7. So guys, there you have it, right? Okay, so that covers evaluating double angle identities. I hope this video helped, okay? Again, it's all about really knowing where your triangle falls, labeling it, finding sine, cosine, tangent, and then plugging it into your double angle part, okay? So hopefully this helps. Tomorrow will be an asynchronous day, and then Thursday we'll introduce inverses, okay? All right. Thanks, guys. That'll be it. Have a great rest of the day. Talk to you tomorrow.